So this is the worksheet that we did Friday, and some people seemed confused about it, so we're going to go over it right now. So this is about reflections, and up here it has a little definition. It says, you can reflect any shape by flipping it over a line called a line of reflection. So first, we're just going to practice doing some really basic reflections. And the first question tells me to draw a shape on the patty paper and draw a line next to it. So I'm just going to draw a triangle, and I'm just going to draw a line, and I'm going to leave some space over here. And then we have to flip this triangle. We want to flip it over this line. So to do that, I could just try to freehand draw it over here, but I think what's going to be more effective is to crease along the line. I saw some people doing this. And to trace it on the other side. So I'm going to trace it right over here. If we look and go, we essentially now have the reflection right over the line right there. So we took the triangle and we flipped it over the line. Okay, so a lot of you might ask, why are we doing this on tracing paper first, when we're going to usually be doing it on a coordinate grid? And the reason is really because when you have something like this on the coordinate grid and you're trying to, say, reflect it over the y-axis, doing it on tracing paper is a really good way to check. So if we had our shape somewhere over here, and we wanted to check that if we were right, we could just take this, trace the shape like that, trace the y-axis, fold, line that fold right up with the y-axis, and now we can see exactly where our triangle is going to be when we flip it over that y-axis. So the next problem asks you to use a ruler to do a reflection. So if you notice here, every point here is the same distance from this line of symmetry as the corresponding point on the other side. They're both the same distance from the line. So what we can do, and what I saw a lot of you doing, is just taking these three main points here and measuring the distance to the line, and then measuring the same distance in the other direction and putting them over there. And we have our coordinate grid, and our coordinate grid, it kind of acts like a ruler. We have spaces on it, and we can measure the number of spaces from, like, say, point C to the y-axis. We're flipping it over the y-axis, so that's our line of reflection right now. And then we can measure the same distance in the other direction and put C prime. Here's B. It's 4 spaces away, so we go to the y-axis. We measure 4 spaces, 4 spaces in the other direction, and we can take it to B prime. And then we can just do the same thing with A. You should get something that looks like that. So now, moving on to the next sheet, we're going to reflect this over, does it tell us to do it? Or tell us to reflect it over the y-axis. So we're going to take this. This is now our line of symmetry, and we now have a lot of strategies for how to do this. We can measure out, label them A, B, C, measure the distance to the line, and measure the same distance in the other direction. So that's what I'm going to do quickly. So here, I can do it even faster by saying here, we're at x equals 7. So that's 7 spaces away from the y-axis. We want to go 7 spaces in the other direction. So now we're going to end up at -7, and the height isn't going to change. The height of the point is still going to be the same. We're going to have -7. 4 is our space for C prime. And doing the same thing, we should be making that shape about right there. And now from this, we can sort of use what we figured out here and use our definition of a reflection as something that takes a point and puts another, and maps it onto another point, which is the same distance away from the line of symmetry in the other direction. And we can make a rule for where each point on here goes when we flip it over the y-axis and we flip it over the x-axis. Okay, so I reflected it over by measuring the distance between each point and the line of symmetry and measuring the distance in the opposite direction to get the corresponding point. And I'm pretty sure I did it right, but I just want to check. So I'm going to take out my tracing paper, I'll lay it on here. I'm going to draw over my line of symmetry, which in this case is the y-axis. I'm going to trace over the original or the pre-image. And then I'm going to fold it right over that line of symmetry. And line it up again and see if it goes right over my image, right over my reflected image. And I can tell that it does. It might not be so obvious on video, but from here I can see that it does exactly overlap my reflected image, so I know that I did that right. Now I need to find a rule which will change each coordinate on this original to the corresponding coordinate on the image. So I'm going to find all the coordinates of this shape. We got A here, which is at 1, 6. B is at 7, 6. And C is at 7, 4. So then I'm going to look at the images. Now I'm going to look at the reflected coordinates. We got A prime goes to -1, 6. B prime goes to -7, 6, and C prime goes to -7, 4. So what it looks like happened is that the x coordinates became negative and the y coordinates stayed the same, and I'm just going to do a quick common sense check that that makes sense and that that's always going to be true. Well, the distance between the line of symmetry and the points on the original actually is the x coordinate. This distance between the y-axis and, for example, coordinate C, that's 7, and that's also the x-coordinate, 7. So when we move in the opposite direction from the line of symmetry, we're going to be moving the opposite way along the x-axis. The x-coordinate is going to get smaller, and we're going to end up at -7. And I can tell that this is going to be true for each one of my coordinates. Now I'm going to check if the y-coordinate, if it makes sense that the y-coordinate stays the same. Well, when we flip the image, we're not changing the height of any of the points. A here is at the same height as A prime, B is at the same height as B prime, and C is at the same height as C prime. So the y should not change. Okay. So now I'm going to write a rule for it. I'm going to do it in the same way I did my translations rule. So x, y, I'm going to say is any point on this original image I'm going to represent with x, y. It's just some point here on this original, right, we're going to call x, y. And now I have to change x, y to make the corresponding point on the image. So what do I do? How do I change the coordinates of any point on here to make the corresponding point on here? Well, I make the x negative, and I don't change the y. So the rule would be xy goes to -x, y.